Hello everyone, so welcome back. Now let us continue our discussion on recursion and let us try to solve the question which I gave to you in the last class. Now the question, as we already know, is something based on the way we understood PMI. But yeah, I'm going to solve this question for you, draw everything and actually do it the way you should be solving first 20-25 questions in your recursion journey. Okay. So the question says that I have to find sum of all natural numbers up to a given number n. Now, if I have to write what exactly that would mean is, if I have to write sum of n, that would be something like n plus n minus 1, n minus 2 and all the way to 1. If I just see this particular equation properly, then I can say that this can be reduced to something like sum of n minus 1, right? So just this whole I would say expression is nothing but sum of n minus 1 natural numbers. Now you will see that, okay, I have actually formed a recurrence relation or recurrence function, right? So this is a recurrence function which I know, which I can use. Now let us talk about what exactly is recursion tree, and that then is when I would say we will write the code for this particular problem. So recursion tree is actually the same I would say function call which we used to make. So let's say if you are given a particular n, right? How this is gonna solve the problem is it's gonna call to n minus 1. Then this is gonna call to n minus 2 and all the way till 1. This whole thing is gonna basically get reduced. We are gonna see an example of this. So let's say if it is for 5, it's gonna call for 4, it's gonna call for 3, this particularly gonna call for 2, and then we are gonna call for 1 in the end. Now we are taking 1 as our base case, so that should be fine. Like we have to draw till the base case, or we have to just at least tell that, okay, so for example, I have drawn dots here till the base case. Now, if you will see here, I will just can actually solve the question using this. So I can just show you that, hey, 1 is getting returned here. This is gonna, let's say, return 3. Now exactly what is gonna happen, that of course we are not gonna do, but in the context of recursion tree, you should be having an idea of this. Like this is exactly what recursion tree is, right? So now let us try to solve this question, and I'm going to solve this question with all the, I would say, principles of PMI only, because that's what exactly on I would say your recursion is based. So the very first is the base case. If my n is 1, I know that my answer is going to be 1 only, right? So this is just my base case and I can write it as step 1. Second part, I have to write my small answer or small value or small output. Now I know that, okay, if I have to find for n minus 1, right? So if I have this recurrence relation and it is going to help me. So this is actually what my small output, small answer and everything is. If I use this, then you can see that I can just directly call for that and I have to assume that I will get my answer. I will get my answer. So even if let's say you are calling it directly for 500, I have to just assume that, okay, I am getting my answer. And if I am able to now using this particular answer, find my answer properly, there is nothing which I should worry about. Principle of mathematical induction says that I will be able to get my answer and there is nothing wrong which I'm doing. And now I'm good to return the answer as well. Okay, so for the time being, let us just do it for 5, because for 500 at least I will not be able to draw that. So now let us see that, everyone. So pay attention. What exactly is happening here is something like this. We have actually now called this particular code. Okay, so I'm just writing this sum as the function. We call it for n is equals to 5. It checked if n is equals to 1 or not, and it actually then call on line number 5. Okay, so this line number is very, very important as well. Let me write this in green. On line number 5, it wrote, it basically called for n is equals to 4. So the function for n is equals to 5 is still waiting in the stack. It is still like, hey, get me the answer and then only I'm going to get resolved. This is gonna call for at line 5. It's going to be for n is equals to 3. Then we can call for n is equals to 2. And finally at n is equals to 1. So sum function is going to get called. So again, if you will see the steps which I have followed, I have not drawn this earlier. First I have written my code, and that is something which I want you to all to follow as well. Because the reason I have taught you PMI is because if you draw this earlier without, I would say, without writing your code, you will never be able to write your code. You will always get, I would say, fixated or confused in this particular full functioning or working. And that is something which I don't want. And you're going to see that how fabulous this overall technique in future difficult question also going to help you. So again, this is the 5th line, this is the 5th line on this, which is waiting. This particular code on line number 3 returns you with the value of 1, right? This, see that, hey, I've gotten my small answer as 1, and let me calculate and add and get my answer, which is going to be 3. Similarly, this 3 is going to return 6, because 3 plus 3 is 6. This n is equal to 4 is going to get its small answer as 6, and answer is now going to be 4 plus 6, which is going to be 10. And finally, I got my small answer 10. I can return 15 as my answer, which I should get here. And in a similar way, for 10 also, we can get the same answer. Like for 10 also, the working is going to be the same, but you don't have to write it. That's the beauty, and I would say the magic of PMI and recursion, right? So let us see this everyone once. Let me just run it. And you see that, okay, we are getting 15 and 55. Now, just to show you one more time to like have all your doubts clear, I'm going to just show you again in Python tutor as well. Again, this is very important so that, you know, each and everything is clear. Like when I was learning recursion, of course, I didn't learn that way. So I have to face a lot of problems. That is something which I don't want all of you to face, right? So let us start with the working. Yes, this function is going to get defined. I'm going to write this function for n is equals to 5. Like I'm calling this function for n is equals to 5. It's going to check. It is not the case. It's going to call for 4, 3, 2, and then 1. Okay. Now, if you will see, 1, we have the answer. So it's going to return with 1 as the value. In my 2 now, small answer is 1. And my answer, which I'm going to calculate, is going to be 3. Now, with 3 as an answer, I can return. And again, I can just calculate all these things. Answer is going to be 6. Answer is going to be 10. Answer is going to be 15. And finally, I get my answer as 15. There's just one thing which I would like you to all to pay heed to. See, if I just find for 1000, right? And let's say in many questions, it can happen that you might have to increase the recursion limit sometime. So this is an easy code, well enough easy code. If someone has set recursion limit, let's say to 500 in some, I would say, environment or in some particular lead code or some other case, you might have to increase that, because if I'm going to run it, it's going to give me the error because it's saying maximum recursion depth exceeded. But we know that, okay, that's not the case. So maybe we can send it to 5000. Normally, again, 2000 is the acceptable limit, but yes, now we can get the answer, right? So we are able to get our answer. So again, like nothing to, I would say, worry on. This will not be the case. Many platforms and everyone, they have the recursion limit, which is in, I would say, which is where your code will run. But yes, this is something, because many times it can happen that if where this code is being ran, okay, and your recursion is going a lot deep, so you might have to set this recursion limit as well in Python specifically. Okay, so I've already explained you on this set and get recursion limit. Again, something to be known if you are specifically coding in Python. In C++ Java, that is not the case, so should be fine. And again, if I am running this, this is going to be fine. Now, I hope all of you have seen that exactly how we have written this code, what are the steps I have followed, how I have made this recursion relation, and how I have drawn this recursion tree as well. So I hope this is all clear. Now, in the next class, we are going to do some more questions, and with these basic question, your understanding is going to get crystal clear. And once that is done, then we are going to move to some advanced level questions where we are going to use arrays and list or arrays and strings as well in our recursion code. Okay, so cool everyone. Thanks a lot. I hope everyone is able to understand recursion. Okay, please make sure that you just see this class again. Try to write the code first yourself and just follow all the steps which I've told you, and you will never face any problem in recursion. Okay, thank you everyone. So let's meet in the next class. Thank you.